Hello, everyone. Sorry for the title. I know. I know. All right. Imagine at the beginning of a system, like a credit loan system, and you build your system around a status, and the status just goes from your loan application is submitted, and it's under review, etc., approved and funded, and maybe sometimes going to be denied. And another system as well, a distribution system, same thing. You have the order status, and it goes from place to confirmed, prepared, shipped, and sometimes canceled. Right? And everything's fine so far. And now we move on, we move over time. 10 years later, what we have now? And have a look there, done. Oh, wow, what have we done? Oh my God! Look at this number there, 29 status. And look at the last one, manually managed. Wow. That's totally, you don't recognize anything, right? And look at the other cancellations. It did happen, we had to introduce that at some point. Cancelled but not refunded. Why not? Refunded but not cancelled? Oh my God! How did we end up like that? That's a good question. Oh, look, there's a new one. But now we have the answer. We ended up like that, one at a time, right? And now you are working with a team or you are consulting with companies, and they tell you, we are trying to split our system into bounded context, but our contexts are too coupled for many reasons, but also because of that. And we need help. And so the point of this talk is to go through a number of ideas, and one of them, overall, the big idea is we should approach and handle time in a way that aligns with its natural flow and direction and the rules behind that. And then we can be more effective in dealing with this complicated mess. All right, I'm Cyrille Martraire. I'm from the company called Arolla. I'm very happy to be with more than 100 colleagues, all passionate about everything DD, as you know, the TDD, the BDD, the DDD, and not just that, but also everything crafting architecture. And we do that for a living. We do training, consulting, and projects. And we love that. And also buy your books. I wrote 1.5, and with my colleagues, the other one. The other one is in French, unfortunately, so it's not for all of you. All right, coming back to our topic, let's consider the usual e-commerce system because it's not that complicated. Just looking at the screen, we have a status, and of course, things should happen from one step after the other. And by the way, this system usually was built as using this field to deal with the workflow. The workflow as one field, as my colleague Christian would say. But e-commerce for real is more complicated than that. If you go inside the building, and you're going to see a lot of people taking care of customer support, dealing with incidents on the phone, and sometimes it's heated. If you go to the warehouses, you can see a lot of storage and all these things for standard items, but there are also storage for small items, and they also have storage and taking of the shelves for very heavy items. And when you have very heavy items like that, sometimes you get it and you destroy it. These things happen, right? Sometimes it's out of stock, and it should have been in stock, but no, there's nothing on the shelf there. And then you go to packing, and people have to take the things from on the packing table, and they have to put it into the bags, into the parcels. But sometimes they can't because it was lost before reaching the packing tables. Sometimes it was lost even before shipping. It's somewhere. And if it's lost somewhere, it also means that it's going to reappear. How are you going to deal with that, right? And then you have shipping. And shipping as well, a lot of things, bad things could happen, you can imagine, and returns, and even invoicing can go wrong, you know. Everything can happen. And that's why this is a business. That's why we need professionals for that, and we need multiple areas of expertise to deal with all that. And we are in the domain-driven design conference, so expertise goes with bounded context, right? And we end up with a number, usually more larger than that, of bounded context with experts in each taking care of all this stuff. And they could work independently, but they can't, because of course, to be able to pack, you need to pick first. It's a prerequisite. And to be able to ship, you have to pack first. It's a prerequisite most of the time. And so the process is distributed, but it's not just distributed, it also evolves over time, and so you have a flow of time evolving through the system, and it doesn't evolve in a random order. It evolves from one cause to multiple consequences, which again has consequences. And so you end up with consequences, having consequences, until it became very complicated. You recognize your work now? Every day you are dealing with that, with just your brain power. That's hard. Now, it was at a large scale between bounded contexts, but now if we zoom inside the bounded context, it gets worse. We have multiple entities. And so let's have a look. You have one purchase order at the beginning, but then you have 2 items on it, and some items are from this warehouse, and some others are from the other warehouse, so you end up with two preparation orders, right? But actually you had 3 items, and one was not available right now, so you end up with 3 shipping orders. The other one will be next week, when they become available. The opposite can happen as well. You have multiple purchase orders, but they are on the same day, so you can group them, or they are on the marketplace, and so you can group for payment. But the payment, you had a voucher, so you want to pay in 2 steps, and it becomes 2 payment operations at the end. It's all like that. You see, it's one too many, many too many. I know, actually, it's just a matter of time because your relationships between entities end up being many too many everywhere. You don't have to do it right now, but it's gonna happen one day. So you go from cause to consequences, multiple cause to consequences, and like that. And the direction of the flow is the direction of the causality. So what do we call causality? You know it, because I'm pretty sure that's a word you know well. It just means we refer to the way in which actions or events, typically in our case from one bounded context, can trigger consequences in other bounded context. Maybe trigger is not a good word, by the way. And we end up, when we follow this flow, we end up with something like a tree. And to be honest, it's more like a DAG, directed acyclic graph, because you see some nodes may have multiple parents. Well, it's just as simple as a tree anyway. And that's the thing we are dealing with every day, actually. They are causal composites. And they are distributed. So they are causal and distributed. Let's look at this pretty picture of a waterfall, peaceful. And now I'm going to fuck it up with causality. You see, one little stream, everything's fine at the beginning, and then you end up with multiple streams. Nah. And it's even worse than that. It's not even instantaneous. Everything evolves, but they don't evolve at the same pace. Here, you have a manual step, so you are waiting for someone completing the job. It may take 1 day, 2 days. You don't know. And so in the meantime, something else can progress. And things can happen at the same time in parallel. And we want that more now because we want to complete the full thing as soon as we can. But here we are waiting for an external provider. So again, we have to wait. And so the pace is complicated. And then you may succeed on everything except one of them, and then you also have partial success. I think we agree with you that these kind of things, we deal with them every day, but they are increasingly messy because distributed causality and different timing all these things, they fuel the entropy we have to deal with. You know entropy? That's your business process. You start from something simple, and it becomes disordered. It works so well that you can even know what is the direction of the time by looking at the state of the system. Which one comes first? Pretty much all of the time, it starts from the left. It starts ordered, and it becomes messy, right? All the time. The walls usually don't build themselves. They collapse themselves on the other hand quite easily. It's more likely. So these things are hard, and that's one of the key things I want to share with you right now is this. Even if it's just an intuition for you, it's that these things are hard and don't even try to fight them. This entropy is stronger than you, it's stronger than I. The time has a natural flow, and we just have to learn how to go with the flow. And that's what I call the Causality patterns. All right, so concrete examples now, how can we model that? The first thing, once done, the thing is done. You have a purchase order, the ID is 123, it's finished, you commit it into the DB, for instance, and then consequences happen. And now you have consequences 1, 4, 5, 6, 7, 8, 9, and they can, of course, they can refer to where they come from. I come from 1, 2, 3, and they can commit their transactions, and again. And this way, everything works fine. Unfortunately, that's not what I see in many systems. What I see a lot is you create the thing, you create the consequences, and then you come back modifying the initial thing so that it can have the ID of the delivery ID, the tracking ID, the invoice ID within the thing that caused the other thing. So you see how you take time in reverse? It's bad for many reasons. It's undesirable for the mutability of the thing. It creates logs in the DB. It creates coupling, backward coupling. It makes your thing even more of a mess than it was already. So you see, immutability is nice. Mutability is okay when you really need it, but being mutable for bad reasons, no. You can avoid that. You see? So we want this. And that's the very immediate and simple pattern I want to share with you. And now let's come back to the order status, the one you want to see on the screen, because we started with the workflow as one field, but at this time we had the assumption that the process was always linear and going through the ideal way. Life is not like that. It doesn't go always as simple as that. We have a distributed process, and each of these processes actually is itself a smaller process, like this. Each department, in each bounded context, you start from something to be done, and you do it using multiple steps, and until you complete it. Putting all this together into a big table, the real process is like this, and here we only have 6 bounded contexts. And so we go from there to there, to there, to there, down, and we evolve. And that's that's the overall process. And this is only one indicative flow here. That's the ideal one. But there are many other possible flows that could happen. You see, I didn't even put many states locally, but we can have, even if we have that few states on each bounded context, this also creates a lot of possible combinations. You're still with me on that? Yeah? You see, it's the possible state of the system is the Cartesian product of all the intermediate steps. But you could say there, hey, Cyrille, all these states, most of them are impossible. Impossible. There's no such a thing in real life. In real life, everything can happen. It's messy as you cannot imagine. All these mistakes, all the things will happen. So actually, a lot of these states will happen. And so where I'm going to is that in the order table, if you look at the status of the order, the status of the order is changing all the time, not because the order changed, it didn't, but because everything else changed. That's mutation we could avoid. It's bad. And so let me show this diagram that I like. I know it's very hairy, but basically you see all the bounded contexts there. They have the expertise, they do their thing, but we end up having a status of the order that tries to do to represent every possible state we are in. And doing that, we are leaking the encapsulation of the bounded context. We are leaking knowledge from all of them. What you call the order status is not about the order itself. It's actually about everything. And that's why it grows so huge, because we progressively enumerate all the possible combinations that we discover over time. And what we called the manually managed actually just represents every other combination that we haven't done, that we haven't properly automated yet, basically. That's what it means. Oh my God. So now imagine you are the customer and you want to know what's the state of my order, right? And the answer is, it's a bit there, and there. That's what you have, really, right? Of course, you cannot say that, so we have to take care of the customer experience, so we build stuff on top of it, probably a new context, that takes the states from all other bounded contexts and makes it into something convenient for the user. But what we mean when we do that is that this order status is really a UX thing. Okay? Make sense? That's obvious, maybe? And that's what Alberto calls the surface language. There's kind of bounded context dedicated to a persona with a different language that try to simplify and makes complicated stuff from the other bounded context to make it easier to deal with by some persona you are addressing, typically your customers. So now if you still have the status order in your the status column in your order table, you may keep it, but you have to think of it as it's odd to be there. It's something different. It's a read model from the customer experience context that happens to be in the order table. And that has a totally different life cycle. That's it. Okay? And this status is actually the projection from a lot of states everywhere. And you can write the truth table a bit like this. And this truth table shows that whenever we progress over the various contexts, we modify the status. Basically, the projection function is more like you should go the further and the most completed in each. You try to simplify that into one status. And whenever you have an anomaly, you make it into, hey, you have to do something, you have to call support or whatever. So customer status is just a projection from all the local statuses. So far, so good? So what about the cancellations? Cancellation, do we mean that we have to go backward in time? That's what it means, naively. We've been we had an order, we've been going through the consequences, and now we want to cancel. Pretend it didn't happen. But it did happen. We are there, and there. So reverting means actually moving backward and trying to revert the consequences. But it was hairy in the first place. Reverting may become hairier. I'm afraid about that. And what's the literature on that? It's sagas, orchestrations. And we have if you have the nominal orchestration for dealing with the nominal case, purchasing and the consequences, then you also have the reverse. And this thing pretends to be linear, but then you have the reverse, the compensation, from where you are, and this one is even more complicated than the original one. And you see there's a kind of mirroring between them. And in real life, it's even worse than that. Recently, someone told me that if they have 50 transitions in the nominal case, they have twice as many for the compensation. That's what it means. Because entropy, because it's hard. And don't even try to fight that. So maybe we do it wrong. Maybe, what can we try to do better? Well, if the first idea would be, what if you could undo using a similar flow as doing? You may not always be able to do that. But the idea would be that what if undoing was just a special case of doing? So for geeks like me, what if canceling an order for an item would be undoing an anti-item, right? Come on. It doesn't exist. It does exist. For real. Yeah. Turns out that it's more common than you think that you can do that. I'm not saying you can always do this, but if you work in storing and moving code and data in Kubernetes, these kind of things, it may work. And it's a case of logistics, of stuff you can lose. You can discard memory. But if you move more fungible stuff, it may work as well. Financial instruments, guarantees, these kind of things. And every time you are dealing with promises, you may as well do something like that. It may work more than we believe it can. Appointments, medical appointments, these kind of things. In this case, you actually can, if you can do locally, you can undo locally by just asking each bounded context to do the opposite. And turns out, the experts within each, they know better than anyone else how to deal with that. Not only they know better, but they also have all the data locally to decide what's best to be done there. So they know best how to do it, and they know best the state and the data to do it best. What about amending now? When we want to change the order, could we do the same? Could we have this causal symmetry? Again, what if we considered amending as a special case of doing? What would it mean to do it in a smarter way? So here I will take inspiration from Terraform and Puppet. You may probably know them. They are known to be declarative and they work towards goals. What does it mean? It means, to quote Romeo, my ex-colleague, tell me what you want, what you really, really want, and instead of telling me how to get it. And the idea is called, in the programming field, we call it declarative programming. Don't tell me how to do something, tell me what you want. So Puppet, for instance, if you want a process to be there and on this machine and to be up and running, you just say, I want this process on this machine up and running. And Puppet has a look, hey, and sees that the process is already up and running and does nothing. Or it sees that the process is there, but it's not running, so it just starts it. Or it doesn't see it, and it has to deploy, start, etc. Okay? That's very simple an idea. So how could we do it for picking, for instance? Instead of saying, hey, I want to do this, I want a picking request, you would say, hey, I want this item on this packing table. That's what you mean, actually. You don't care, it's called picking or whatever. They know better. So you say, I want this item on this packing table, and the picking subsystem, and the people with it, they know better that it's supposed to be a picking task, and they can group the picking task. They can do a lot of complicated things. That's their job, as long as I get my item on my table. And we can say now the picking is done. And reverting, just that I want the item back to a place where it should be. That's what it means as well. So the same kind of things. So this idea is very promising, but to be able to do it, it works better when you have this property that you can diff between things. And that's a very powerful situation, and I suggest now that you keep on looking how I could do that. If you think about it, a purchase order actually is you want some items to come from wherever they are to your house, right? That's the declarative view of it. And now, when it comes to amending what you wanted these 3 items. In the first order, you ask for these 3 items because you want to start a Twitch meetup about domain-driven design, for instance. And now you change your mind. Hey, I forgot the neon light for the proper setting. So imagine you had this order already there, and it's already getting prepared. And now the system on the bounded context could say, hey, I've already done this. I can do the diff and only prepare for the difference. That, ladies and not ladies, is a group theory applied. So I'm a big fan of monoids, a mathematical creature. But groups basically are monoids with inverse. So you can do the anti-things of things. And it happens if monoids are everywhere, groups are not everywhere, but they are frequent enough that's worth thinking about them. And they can make your system much, much smarter when you do this undo, do, and amend symmetry if you go goal-driven and use these kind of ideas. All right. I think we need to relax a bit after this thing. And we're going to relax by focusing on another coupling issue between contexts. And this one is straightforward, so we're going to go quick. It's just to relax ourselves. Typically, when you start an order, again, typically you start with a screen and you have to collect all the information, the payment information, the invoicing information, the shipping info on top of the order itself. And you collect all them, and what I see a lot as well in many systems is that then the first system, typically the ordering, has to redistribute the data to everyone else. It just works. But it's a bit brutal when things change, because now, whenever this payment context needs to evolve, hey, I need this thing on top, you need to change the UI, but you also need to change maybe the ordering thing. I know there are some solutions. You could be generic in the middle, but usually it happens with coupling that could be avoided. And so and it happens every time. So one alternative to this as well would be to just go more federated. the way microservices are supposed to be. And in this approach that I want to mention, something basic, huh? You probably know that already, but it's worth mentioning again because I don't see it that many times in the wild. We would evolve, instead of going path-through, we would directly have the different data be sent directly to their target bounded context. And there, they would each commit them the way they like it. All right? So what's wrong with it? So far, the order is still not placed. And we already committed stuff everywhere. And now, when we place the order, we just tell everyone, hey, now you can start do your thing. Do your magic now. You trigger everyone to start the processing. So far, it's all well and well, and when it's going to evolve well, when it's going to evolve independently, which is what we like. But now, what if we abandon the order, we never place the order? You see, we have orphans everywhere. Is that a problem to you? I'm really asking because I usually find people they hate that. They just hate it. But what's wrong with this? We can just accept to have orphans, accept to have orphan entities. That's all. Or really, if you want, you can have a batch, clean that in 1 month or 1 year or whatever, but it should not be. And in the meantime, when we do that, we start to pay attention to one thing, is we have opportunities many times to separate two things, which are, one is passing the data, the other one is triggering things. And usually in object-oriented programming languages, when we do both at the same time, when we do a message call. But they don't have to be. We can have them separated over time, and this can help untangle complicated situations. All right, we relax now? This one was easy, right? You see the kitten here is looking at the food already. We are waiting for that now. So when I gave this a couple of weeks ago, I was in Paris doing the same session, and my friend Romeo Moura came on stage and crushed into my talk at this time, and saying, hey, it's all about the composite pattern indeed. Everything we've seen is a composite pattern. You agree? It's all about the composite pattern? Yeah. And Romeo was saying, when you eat a kebab, each part of the kebab is a kebab for you. You don't care, it's tomatoes, salad, bread. It's all kebab. Like this. It's all kebab. And he would elaborate on saying that when you eat the little part of tomato inside, this tomato, for you in this moment, is a kebab. And people would go crazy, just like me, trying to mimic them. That's totally crazy and stupid. A tomato is not a kebab. But in the context of eating a kebab, it is, because it is just something edible that you like, right? That's what it means to do domain modeling and to be in the right bounded context. In the right bounded context, you can make this assumption that things that are different, you see them as the same thing for your purpose right now. And that's what it means to be a composite. It means that you have a unified interface over different things. And in particular, the composite patterns means that you have the same interface for things that are singular and that are plural. Said otherwise, if you had in Java or C# an interface called kebab, you would have bread, tomato, salad, and sandwich all implement kebab, sandwich being the composite because it's built of every other things. And you could do again saying that the kebab plus the drink is a kebab. Maybe that's abusing a bit, but we could go on and on and go on. Everything recursive would be like that. And it takes a deliberate effort to do that. Usually, you don't have it by random chance. One of the first blogs I wrote long ago was just on that. I was working on financial instrument, and they had some currency, get currency getter. And usually, it was used to filter instruments by every USD instrument, every euro instrument, and these kind of things. And we had also instruments that had multiple currencies because it exists. So the getter was a getter with a plural, with a set as a return. So you see, they are not unified here. What could we do to make them unify and remove the if statements that you need? Because here you need if it's a singular, I need to call this method, otherwise I need to call this one. The if is on the color, which is not unified. It's not nice. We could do it brutal by forcing every instrument to return all the currencies, but I don't like it. And the alternative was, what do we use this thing for? We use it to filter. Maybe you can just use a method called is in this currency, I pass a currency, and you tell me yes or no if you belong to it, if you have some exposure to it. And this way, you can go to a unified method for everything. And that's the key idea behind the composite pattern. So because Romeo crashed my talk, it was staged, of course. Because he crashed my talk, people on Twitter noticed that the talk itself was becoming a composite. Okay, that's the geek part. So this composite pattern is all stuff from 95. When can we learn from it? We can learn that the composite usually can be built on top of any kind of multiple structure with multiple things inside. But there's one more thing. There's also the way you traverse the structure. Remember going through the flow of the tree? Usually we traverse a tree, but there are more than one way to traverse a tree. Remember this one? Remember this thing from the school? You can go depth first, you can go breadth first. You could go as well topological sorting, and that's the one I want to conclude the talk on, because it matters. You remember what it is, topological sorting? Who remembers? No, more than one. You don't dare. No. Yeah. That's the key ingredient. It's not hard. It's the key ingredient behind all the build tools like Make, Maven, Ant, whatever. And the idea is that if A depends on B, you have to build B first, and then A. This thing is wrong. I fucked up myself. That's the key ingredient behind Excel as well. When you change cells in random order, there's a magic inside. Excel tries to see, hey, what changed? And then it builds on the fly a topological order to recalculate the results. And when you give a talk, one of the worst things, and I had problems on this one as well, is to be able to introduce this stuff, you need to introduce the stuff before, because you depend on it later. And that's the hard part of doing a talk. And all these things, that's what we call a topological sorting. So the theory says it's just the reverse out order of the depth first search algorithm, but actually it just means you go through a structure, starting the deeper first, and then when you get out of it, you get your topological order. That's as simple as that. But basically, what you have to remember is that whenever you want to sort things by the prerequisite, you just need a topological sort, and that's easy to implement these days. So if we think about these business processes that I mentioned, ideally, the ideal process would be everything parallel, because then we could reduce the completion time, right? If we could prepare, pack, and ship everything at the same time, that would be perfect. So actually, that's what we want to build, except for the prerequisites. And the prerequisites, we mentioned them. We have the picking. You have to pick before you pack. You have to pack before you ship. And these prerequisites is what we need to model as domain-driven design practitioners. And when we have the things and the prerequisite between them, the topological order is the latest ingredient to define the traversal that you need. And that's how you build these kind of diagrams. So we love topological sorting a lot on top of composites. But what I hate is when people have to do this thinking, this topological sorting, manually. I hate that. I'm sad when I see that. And it's something I mentioned at this conference years ago. It's called the human compiler anti-pattern, when we do things that computers could do instead, right? It always makes me sad. And doing topological sort manually on the paper, on a Notion, it makes me sad because machines could do it 100 times, 1,000 times faster, and they could do it repeatedly, they could do it faster, and they could do it on the fly, based on the latest knowledge that you have in your business. How to do that in practice? In fact, you already have topological orders in your systems, maybe in some orchestrators, but most even more probably in everything event-driven, when different parts of your systems wait for some event until they can start do their things. And this choreography emulates a topological sort in many aspects. You agree that? Make sense? Wow. All right, so we are done with the deep content, and so I want to thank my colleagues. What to get away from, who helped me review, and what to get from this talk, if we were to go further. First, learn how to survive a nuclear attack, because that's usually the number one thing to learn. And then, by decreasing priority, have a look again at the composite pattern, because it does matter even right now. Have a look at topological sorting, and then if you want to practice and tell your friends, you may look at the kebab kala and maybe the monoid kala called the panini kala, which is the same, but we do something different inside. And now, because that's the end of the talk, I want to open a bit the discussion on step back a bit. And remember this book, more than 20 years ago? This book introduced this idea that we are living in a world of complexity. And we do live in the age of complexity. And what does it mean to be complex? It means you cannot predict, you cannot solve, there's no best practices or whatever. And we need to think like this, and we basically use this kind of complex behavior. At DDD Europe, we talk a lot about that. And we have to talk about it because not everyone understood so far, so we still have to talk about that. But in the meantime, you still have a lot of complicated sub-problems to address. There, and there. The world is not all complex. I'm saying that because in this conference, we live in a special world where we understand complexity, and we get used to be good at dealing with complexity. But we should not forget that we still have to be good at doing the complicated subpart. And everything causal that we mentioned, everything that I've discussed so far, is just complicated, not complex. Which means we have good practices, we have patterns, we have solutions, we can do rigorous thinking. It works there. It doesn't work in the overall system, but it works there, locally. And if we keep on mislabeling, if we consider everything as a complex situation, we end up with wasting time and solutions that could be better. That's what it means. So it's a fundamental error to do that. So you still need design patterns, analysis patterns, modeling patterns, all these kind of things, even math and graph theory, right? And it's fun. So basically, we are cyborgs now. We have to be able to think complex, organic, and we still have to be good at dealing mechanistic at the same time. And to be honest, the world is complex enough. When you have the opportunity to work on a complicated sub-problem, you have a relaxing joy of complicated problems, as Romeo would say. That's very relaxing, because there it's more deterministic, it works. All right, overall, we should always approach and handle time in a way that aligns with its natural flow and direction, or this metaphor, just like when you pet a dog, you should pet in the right direction, in the direction of the coat. Otherwise, it would bite you, right? That's the same with time. And that natural direction is the causality. Thank you very much. And now you can enjoy the lunch.